Chapter 4.7, Arithmetic Sequences. Your objective for this chapter is to identify and extend patterns and sequences, and also to represent arithmetic sequences using function notation. A sequence, is an ordered list of numbers that often form a pattern. Each number in the list is called a term. That's your vocabulary for the lesson. A sequence is an ordered list of numbers that often form a pattern, and each number in the list is called a term. Example 1, extending sequences. Now for the A and B here, we want to describe a pattern in each sequence, and then we want to list the next two terms. Please do not leave out the first part where it says describe a pattern. So 5, 8, 11, 14. You're going to ask yourself, how do I get from 5 to 8 and from 8 to 11 and then from 11 to 14? So the most obvious thing is you are adding 3 to the previous term. So you're going to add 3 to 5 and get 8. You're going to add 3 to 8 and get 11. You're going to add 3 to 11 and get 14. And for the next two terms, we're going to add 3 to 14 and get 17. And then we're going to get 20. So there's one answer. There's my description. For B, 2.5 to 5, 5 to 10, and 10 to 20. The first thing you may think of is that you're adding 2.5, but that doesn't hold to go from 10 to 20, so it must be something else. So think again. I noticed that from 5 to 10 and from 10 to 20, I'm multiplying by 2, and that's going to be the same for from 2.5 to 5. So we are going to multiply previous term by 2. So that's going to give me 40 next, and then 80 for the next one. Guided practice number 3. Describe a pattern and then name the next two terms. Pause the video here, do these next 4 parts for guided practice number 1 on your own, and resume the video when you're finished. Okay, upon examination, you should see that you're adding 6 each time on A. So we're going to add 6 to the previous term, and our next two terms are 29 and 35. For B, we're multiplying by a half. You could have also said dividing by 2, and the next two terms are going to be 25 and 12.5. For C, we are multiplying by -2. That's why the sign keeps changing. And the next two terms are positive 32 and negative 64. For D, we are adding 4, so the next two terms are going to be 1 and 5. In an arithmetic sequence, the difference between consecutive terms is constant. So in this blank right here, I want you to write the words arithmetic sequence. And in an arithmetic sequence, the difference between consecutive terms is constant. The difference is called the common difference because it's the same every time. So example 2, we're going to identify whether this is an arithmetic sequence. In order for it to be an arithmetic sequence, the difference between consecutive terms has to be constant. So am I adding the same thing every time? From 3 to 8, I added 5. From 8 to 13, I added 5. From 13 to 18, I added 5. So the answer here is yes. They say if it is, what's the common difference? So my common difference is what I'm going to call D, and that's going to be 5, positive 5. For B, from 6 to 9, I'm adding 3. From 9 to 13, I'm adding 4. From 13 to 17, I'm adding 4. But because one time I added 3 and the other times I added 4, this one is no. Guided practice number 2, I want you to tell whether it's an arithmetic sequence. So I want you to tell if the difference between the terms is constant. Pause the video, do these 4 on your own, and then resume the video when you're finished. Alright, so for A, you're adding 7, then 8, so it's not an arithmetic sequence. For B, you are adding 2 every time, so it's yes, D equals 2. For C, you are subtracting 6 every time, so it's yes, D equals -6. And for D, you are subtracting 4, adding 4, subtracting 4, adding 4. So the answer, so it is not an arithmetic sequence. A blank is a function rule that relates each term of a sequence after the first one to the ones before it. That's called a recursive formula. So that's what goes in the blank right there. For example 3, we are going to write a recursive formula. This is the easiest one to write. So, and then they want to know what the 8th term is. So we've got the sequence 70, 77, 84, 91. You need to, first thing you always need to do is look for the pattern. So what I'm doing each time here is I'm adding 7. So my common difference is 7. To write a recursive formula, you always need to state the first term. So that's A sub 1. That means the first term, and the first term is 70. Then we're going to go through and we're going to say that the previous term, now to state any term, you're going to say the term n. So if I want to state the term before that, we're going to do A sub n minus 1. We're going to take the previous term and we're going to add 7 to it. And that's going to give me any term I want. So my recursive formula is going to be A sub n equals the term before it plus 7. So they asked for the 8th term, so we're going to take the 8th term, A sub 8, is going to be the 7th term plus 7. So we're going to keep that going. This is the first term, second term, third term, fourth term. The 5th term is going to be 98 because you add 7. The 6th term is going to be 105 because you add 7. The 7th term is going to be 112. That means the 8th term is going to be 119. So A sub 8 is 119. You got 2 answers. The first one was the recursive formula, and the second one was the 8th term. Guided practice number 3, we're going to write a recursive formula, and this tends to be very difficult for students, so I'm going to do it with you. First, identify the pattern. So you'll notice that you're adding 6. So it's the same thing every time. The nth term is going to be the term before it, A sub n minus 1, plus the common difference. So plus 6. And then you always state the first term, so you have somewhere to start. The first term for the sequence is 3. They want to know the 9th term, so we're going to continue the pattern. We're going to go 21, and then it'll be 27, and then 33, and then 39, and then 45. My pen is not writing. And then 51. So A sub 9 is going to be 51. For B, the pattern is add 12. So you're going to say A sub n is going to be A sub n minus 1. That's always the same, plus the common difference. Then you state your first term. Then they want to know the 9th term, so we're just going to continue the pattern. Add 12, and you get 71. Add 12, 83. Add 12, 95. Add 12, 107. Add 12, 119. So my answer for B is going to be A sub 9 is 119. Next, we're going to do another type of formula for an arithmetic sequence, and this is an explicit formula. And this formula is helpful when you want to go directly to a certain term instead of having to do like we did here and go term by term until we get to the 9th term. So if they ask you for the 45th term or something, you don't want to do that. So you're going to use the explicit formula, and there's kind of a little pattern you follow. You do a sub n is going to be a sub 1, or the first term, plus n minus 1 times d. A sub n is the nth term. So that's the term you're looking for. A sub 1 is the first term. You should always know that number. Then you have n, and that's the number term they ask for. So the term number, like if they ask for the 45th term, you put 45 there. Then you have the d, and that's going to be the common difference. So let's do some examples. I'm going to leave that at the top of the screen so you can look at it. Example 4 asks you to write an explicit formula. So what you're going to do is I'm going to rewrite my formula for an explicit formula of an arithmetic sequence. And then I'm going to fill the stuff in below it. So everything's going to get replaced except for the n. So for the explicit formula, we're going to write a sub n equals, what is the first term? It's 200, so we're going to replace it. We're going to replace we're going to leave the n where it is, and then we're going to replace the d with the common difference. And the common difference with this one is that we're adding 20, so we're going to put positive 10 there. So my explicit formula is a sub n equals 200 plus n minus 1 times 10. And then when they ask for the 12th term, that's where we get to replace the n. So the 12th term is going to be a sub 12. And we're going to write everything like we already have it, except we're going to replace the n with the 12. It'll be 12 minus 1 times 10. And then you just evaluate that. So it'll be 200 plus 11 times 10, which is 200 plus 110 equals 310. So the 12th term of this sequence would be 310. And of course you can check yourself by extending the sequence out to 12 terms and making sure that you get 310. Okay, guided practice 4. I'm going to do this one with you again, especially because it is decimals. So to go from here to here, from here to here, and from here to here, what difference is that? We are going down 175. So it's negative. Okay, so my arithmetic sequence is going to be a sub n equals the first term, 100, plus n minus 1 times the common difference, negative 175. So that's my explicit formula. Then if I want to know the 15th term, I'm going to plug in 15 for the n everywhere in this formula. So it's going to be a of sub 15 equals 100 plus 15 minus 1 times 175. So that's going to be 100 plus 14 times 175. And you just keep evaluating that, and your final answer should be 73.75. Okay, example 5, writing an explicit formula from a recursive formula. They give you the recursive formula here, and they give you the first term. They want you to write an explicit formula. So from this explicit formula, you can see that the common difference is 12, and the first term is 19. That's all you need to know to write the explicit formula. So we're going to go a sub n equals a sub 1, which is 19, plus n minus 1 times the common difference, which is 12. So that's my explicit formula from the recursive formula. Guided practice number 5. Again, I'm going to do this with you. I've got my recursive formula and my first term. So from the recursive formula, I can see that my common difference is 2 and my first term is 21. So a sub 1 is 21 and the common difference is 2. So my explicit formula is going to be a sub n equals the first term plus n minus 1 times the common difference. And that's my explicit formula. Example 6. Going the other way. We're going to go to a recursive formula from an explicit formula. So from a recursive formula, you have to know that the first term is here. So a sub 1 is 32. And the common difference is here on the end. So it's 22. So to write a recursive formula, you're going to say a sub n is equal to a sub n minus 1 plus the common difference. And then you always state your first term, which is 32. One more. I have my explicit formula, so I know that this is my first term, and I know that this is my common difference. So if I put it in the recursive formula, I'm going to say a sub n equals a sub n minus 1 plus the common difference, and I always state my first term, which is 76. Okay, again, no guided questions at the end. You're going to take a quiz at the beginning of class tomorrow to make sure that you watch the video for understanding. You bring your outline completed and you'll get credit for that. And then you'll also get graded on your quiz. And those 2 grades will go in for a homework grade.